Hey, welcome back to the shop. Today we're going to modify the transmission tunnel to make room for a new Tremec T56 Magnum transmission. I'm going to custom fabricate a new panel utilizing the existing floor. I'll show you not only how I go about laying it out, but I'm going to take you through the entire process. Lots of cutting, grinding, welding, even some metal shaping to get that desired fitment. Stick around to the end, see how it all turns out. I know I'm curious. Let's have some fun. Okay, will it fit or won't it? That's the first question you got to ask yourself. There'll be those that quickly point out that you can fit a Tremec T56 transmission in a stock transmission tunnel on a first-gen Camaro. So why am I modifying it? Well, two reasons. One, driveline angle, and the other, ease of access. So while you can physically fit it in place, depending on what you're doing, it's not necessarily ideal for the final driveline and pinion angle. I'm doing a Detroit Speed hydroform subframe with DSE's solid body mounts and their quadrolink out back. A lowered pro touring stance will challenge your ability to dial in those angles. Getting those angles into the 1.5 to 2 degree range, as I understand it, is ideal. Adding to the tunnel is a huge factor that will allow you to push the transmission up to get the correct angles needed. I'm doing a full build. The car is all the way apart now. It's one of those things. You're already here, you might as well. That way I won't have an issue later dialing things in. In terms of ease of access, well, nobody likes working on anything that's a struggle. So doing the tunnel mod and providing some additional working space around the transmission, it'll save your knuckles and it'll help you avoid some trouble in the future. In a perfect world, I'd have my new engine and transmission mocked up in place, and I would simply modify the tunnel and adjust spacing against the actual transmission, like most guys do. Unfortunately, I don't have that benefit, mainly because I don't want my new engine and tranny sitting here collecting dust and blowing warranties while I get the body whole again. I really want to fabricate the tunnel and marry it up to my new custom firewall now, while I have easy working access to both. So where do you start? Well, the intent is to raise the tunnel up about 2.5 to 3 inches. I've drawn a line at the transition from this vertical surface as it breaks into that corner radius to the top face. I don't want to weld in section on the radius, so where that surface starts to break, I've marked a line and I've taped it. That's going to be my cut line. I will section this piece and raise it up. The dotted line here, I'm not going to cut. That's going to be a fold, because that's going to be the transition. The transition from this level surface and this back piece here, that part of the tunnel remains constant. So this area from this dotted line to this dotted line is the transition to marry the elevated tunnel up back to the stock tunnel. There's a fold line right here at this dotted line already, because this surface more or less stops there. Then there's a slight transition here, and then there's 2 or 3 transitions throughout the remaining part of the tunnel. So the intent is to split this transition in half. I'll cut along this line. There'll be ample material here to bend that surface down at that dotted line, and similarly there, I'll have enough leverage with this half of that piece to cleanly fold that piece up, and then I'll marry the two in the middle in a straight plane and section in a piece and weld it. So the T56 from the front of the input shaft to the back of the tail shaft is roughly 34 inches. So on my car, from the front of that tunnel seam or the hump seam where the white line is to the front of the firewall is 11 inches. So that input shaft on the Tremec back to the base of the transmission is 6.5 inches. Well, a bell housing is, from my research, a QuickTime bell housing is about 5.5 inches. So that would make sense in my mind, because there'd be an inch of that input shaft into the back of the motor. So measuring back that distance from the firewall. So worst case scenario, I assume that the motor is right up tight against the firewall. Okay, so that would push everything back to its furthest extent. I'm not recessing the motor back into the firewall. So from that reference point back, the shifter is approximately, and I say approximately because there's tolerances built within that, and I'm not cutting anything yet. This is just to ensure the layout. is roughly 14.5 inches to that seam back. So I want to have at least a minimum of 4 inches, or roughly 2 inches here, but 4 inches from center of a flat surface for my shifter boot and collar to sit. I want to have a nice clean surface there before I transition down. I looked at many builds at Detroit Speed and their build page on their website, reference the proportions, and I'm confident with this layout. So having said that, I am going to start cutting, and no turning back. Let's move forward. With the help of a little time-lapse video, I plowed through the fabrication to get to this point. To give you a sense of the overall concept, it's easier to see it as I explain it. So again, the top of the tunnel, where that dotted line was, the fold starts down, that transition's cut in half. So there's my upper tunnel piece, and now we've sectioned in a 3-inch strip of 18 gauge steel. So I prepped it, cut it. There's a bead roll here where the toe board panel rests under the floor structure, this being the floor structure. So I've mimicked that bead roll just with a T-dolly into my vise. Use these panel clamps, set that section piece in place. It's flush, tack welded. I'm going to take you through the process step by step. Okay, I flipped the tunnel over. I've cleaned and prepped a 3-inch piece of 18 gauge steel. I've come across, through my research, an excellent tool that works phenomenally well to really clean off mill scale fast, and I mean fast. I like it so much, I'm actually going to do a tool review video on it, and I'm going to be posting it shortly after this video to show you how easily it removes mill scale, and it's a relatively inexpensive tool. I am so impressed. Having said that, first step is to line up the edge and ensure a tight tolerance to this panel. I can clean it up a little better. It's a little high here. I want to get that tolerance as tight as possible. Now it's a matter of laying out the bead roll. So all I've done is simply mark the outside break lines and the rough center line of the bead. I've left a little tolerance proud of my panel because it's easier to grind back to it than welding something on. So that's more or less the area or the location that I need the bead. I use a 1/2-inch T-dolly, and I'm just going to set my piece in the vise and hammer down with the T-dolly and just work that edge a bit to match the profile. So let's head over to the vise. I'm ready to weld. I'm going to do it a little different than the previous side. insofar as the gap here was a little bit large compared to the rest. So instead of grinding everything down to get that even tolerance, I'm just going to work with that and use this panel clamp in this larger gap because it bodes well to get that spacer in between. And then I've just clamped it along the outer edge. Tighter here, fills the void here with the clamp, and I'm going to proceed on that basis. So use my spot weld plier clamp, nice flush surface in between, work it out to out on both sides, and we'll come back with this side tacked in. Well, that goes pretty quick. Here it is, the section pieces tacked into place, that back transition split, bent and held in place with that panel clamp. So you see how that splits the transition and creates that angle at the folds. Let's go to the front. Herein lies the next challenge. Because we've in essence elevated this top section up, created the same angle that was on here. If I move this clamp and set it down, this side rests flush with that side. But now, because we've elevated the outside extent of that radius and the inside extent of that radius, we have to get those two planes lined up like so. So we gain that amount of space within the transmission tunnel itself. Once we get those two angles worked. So now we have to metal shape the tunnel. I can use this clamp to press outwards and work the spring of the tunnel, and through trial and error get these edges to line up, and then similarly at the top I'll compress the edges in towards the middle, get that flushed, and then probably using panel clamps, or yeah, I guess panel clamps probably going to work the best. We'll see when we get there, to line those faces up and begin tacking. Here, just to illustrate that last point, I just set the patch down on the tunnel itself. So you see what I mean? It sits nice and flush. So we'll work those angles and come right back. So I have this reversible clamp that's going to come in handy, because now all I need to do, see? I can press the tunnel out and work against the spring and slowly massage, maybe hammer tap the radius to ease it over and release some of the spring. So I'm going to work those angles, play with it for a bit, and come back. So I'm happy with that. There we go. Panel clamps in, my 3-inch rise sectioned up, transition back at the folds, filler pieces yet to come, but bead roll lines up nice. More room at that front tunnel to accommodate working area around the new T56. My angles are lining up beautifully. Take a look down the face. There, that's a single plane this side. Where are we? There we go. Look at that. Flush. Flush, flush, flush. I'll bring you back. I've welded the panel, attached that 3-inch section to it, dressed both sides. I've circled a couple of the areas where there's slight imperfections, but for the most part, very happy with the outcome. So what I've done, I've welded in a 3-inch section. This radius to the top surface is another inch. So in total height, it's a 4-inch panel. So I've replicated the Bowler transmission prefab panel. Nowhere have I seen this panel attached with panel clamps. It's always overlaid and clecoed in. There's a bit of an overlap. So I'm going to do the same, because I don't believe I need a full 3-inch rise to clear the transmission from the research I've done. I have a 1/4-inch overlap. I've set that line parallel. And now, using the level, I ensure that the tunnel is level, and I've clamped it on both sides. So I'm going to scribe the tolerance on both sides now, instead of cut and butt welding. The panel clamps do afford me the ability to line those two surfaces up parallel, where if I cut and butt with an overlap, I'm sort of fighting a bit of a bend there. I think those panel clamps actually do afford me the benefit of keeping those surfaces flush. So I'm going to trim the bottom, come back with it panel clamped in. So we're back. The bottom edge of my new panel trimmed against the scribe mark, clamped into place. Very nice. I reinforced the front face with a piece of 1-inch tubing just to make sure that those faces are plumb as well. And we're looking good. Okay, so before I tack weld along the bottom, I want to reconcile this slope so it's flush from side to side. I've clamped and pinned that back corner. I'll be able to take this to the bench now, scribe the back because it's locked in by the vice grip, and tack that into place as well. I have to section this radius because it's overlapped, so I'll trim that as well and weld that corner and weld that transition. A couple of those imperfections, I'm going to give it the old zapperoo while I'm at it on the welding table and dress those, make them perfect, and then we're good to go. Oh, here's my printout of the T56 Magnum and all the various measurements I've been taking off of it there, and my cheat sheet to figure out, to make sure that, you know, worst case scenario, I have the flexibility. I just want to quickly show you here what the new tunnel height is from the base of the floor. I have 10.5 inches. The stock tunnel from that same vantage point was just under 8. So I've gained about 2 3/4 inches of additional tunnel space for flexibility. Oh, you can see my yogurt container at the back of the tunnel. To replicate the drive shaft, I figured out worst case scenario, I'd tuck up tight against the underside of the tunnel. That diameter of the yogurt container is 4.5 inches, so that gives 3/4 of an inch tolerance at each side. So then I did measure up from that center line, again, just to figure out and validate the location of the shifter, because I do know that, you know, the shifter base from the center line of the output shaft to the base of the shifter is 4.5 inches. So again, worst case scenario, don't want to get painted into a corner. I'm confident with how everything is shaking out. So let's scribe those corners, start to attach the transition piece, and get this thing ready to tack weld into place. Okay, we're back. If you're liking this video or some of the other ones or the build series, how about hitting the like button, or more importantly, the subscribe button. Got a lot of good content coming in the next little while, so you hit the bell, do whatever it takes, so you can follow what I'm doing here. I'm having fun, and I'm hoping you're enjoying the journey along with me. So having said that, the tunnel looking really good. Sides are plumb, flush, about 80% tack welded in. Some more stitching to do to finish it off and then dress it. Then I gotta go underneath and do it from the underside. Ugh. And if you're like me, the notion of crawling around on your back to access the underside, especially to butt weld above your face with sparks raining down on you, doesn't sound so appealing. I have a solution to that, and we're going to cut away briefly. I'm going to show you how and what I'm doing, and then we'll come right back and show you the final tunnel. Okay, I've modified the jig to mate it up to my new rotisserie. A little shout out to Resto Revolver. I scored this new rotisserie off Kijiji. Unfortunately, a local builder abandoned his project before using it, so his loss is my gain. I wanted the ability to spin the floor assembly around to make not only the tunnel mod easier, but all the Detroit speed fab work that's about to follow. I wanted to make sure I could take the jig from rotisserie to rolling floor assembly quickly to make sure test fitting things back in the car remains effortless. So I picked up these 2.5 inch receiver tubes and welded them on. They simply slide over the rotisserie supports. I lock them down with catch bolts, and when removed, the tubes clear the outer jig and I maintain overall flexibility. While I was welding the receiver tubes on, I thought it best to reinforce all the vertical supports with gussets too. Well, we're back. The floor assembly is up on the rotisserie, nicely balanced. It's secured at the 3 mounting points. I have a bolt through the spring perch, snugged up at the base of the frame rail. Let's spin it around. I've put a sheet metal screw through the frame rail, up through the floor, and secured it back to that vertical post, both sides, so the floor doesn't lift off that locating pin. And at the front, where the front sub mounts, I have a long bolt and washers and a nut, and it's snugged down so the front's not going anywhere. That's locked into place. At the front of the toe board area, I have that rail now sheet metal screwed down to hold the spacing properly. Let's spin it around and look at the inside of the tunnel. One-handed twirl. There you can see nice penetration. Going a little closer. Still lots of daylight through there. I haven't finished stitch welding it from either side, but now I have easy access to finish that welding of the tunnel, dress it both sides, check for pinholes, rinse and repeat until we have a perfect tunnel assembly. I'm going to finish that welding and come back and show you the final outcome. Hang on. Well, here's the final tunnel all welded in and complete. You can see here the angles of the transmission tunnel are actually quite complementary, works out well. A couple videos coming soon. I'm going to finalize the transition from the tunnel to the firewall and complete that hump area. That will be coming. And also going to start the mini tubs and quadra-link installation. And don't forget that tool review or recommendation, how to remove mill scale fast. I'm going to be posting that shortly as well. So check that out. You might be impressed by that tool as I am. But having said that, thanks so very much. Cheers.